Hi class, for this section we're going to start looking at basic predictions. And this is what we're talking about. So we're going to be assuming that the data is bell-shaped. And let me give you what the book is giving us. So if the data is bell-shaped, and in this video I'm just talking about data that's bell-shaped, you're going to be using the empirical rule. And what the empirical rule says the following. So you technically have data that happens to be, well, at most, within a total of 3 standard deviations away from the mean. And when it says within, technically that means 1 standard deviation above, 1 below, or 2 above, and this will be technically 2 below. The most that you're actually going outward from the mean, and we're talking about the mean being, well, technically this value here, it's a total of 3 standard deviations away from the mean. And well, by the empirical rule, you have very few data on the actual edges of any distribution. So the following percentages, you don't have to actually memorize them. They will be given to you as part of your notes on the future exam. And here's the idea. If you have data that's bell-shaped, you're only going to be looking in this section at technically 3 standard deviations away from the mean. Any value that happens to be unusual, which is for this formula, you're looking at technically 2 standard deviations above or below the mean. Any value that's on the outside of that, it's considered to be technically unusual, and those will be your outliers. So when we talk about usual values, that only refers to 95% of the data. And then here you can actually take a look at 3 actual distributions with numerical values, and you can see what the spread of the data actually looks like. This first one, starting on the left, that would be 1 standard deviation. This is technically 2 standard deviations, and the last one will be 3 standard deviations above and below the mean. Here you technically have an actual data set that's bell-shaped. Every one of these actual dots represent values that happen to be within 2 standard deviations above and below the mean. And in this case, this value here actually represents an outlier, since technically it's outside of 2 standard deviations away from the mean. Now, on any of the sketches that you're providing, don't forget that, well, you technically need arrows. When we talk about a distribution, we are referring to a data set that happens to be infinite. So let's talk about a couple of examples where we're using the actual the empirical rule, and we're looking at data that is bell-shaped. So all they want you to do is provide a sketch and shade the percentage of data that's within 1 standard deviation away from the mean. So this value here, it's going to be the values of mu, and we're technically assuming the following. So this is technically, well, 1 sigma that would be above the mean, and this is technically 1 sigma below the mean. So let me rewrite it as mu plus and technically mu minus. So the part that they want us to dot, it's technically, or shade, it's just this portion here, since that is referring to 1 standard deviation above and below the mean. Now, all of these statements, because we're doing predictions of data, actually come with a specific sentence that you're going to be stating. And you would say that by the empirical rule, you have approximately, and within 1 standard deviation above the mean, you're looking at 68%. So this will be 68% of data within, and they just want 1 standard deviation above and below the mean. So we have to state in this specific scenario why we're concluding, and this is the empirical rule, tells us that that is how much data is above or below the mean. And then you have to stay within, because your actual intervals may not be symmetrical. So we're just basically looking at this portion of data that happens to be within 1 one below, and one above. So that's it for this one. The last portion is, don't forget to include that sentence, which is technically standard on any data prediction that we're talking about. I'll let you guys do example 2. Let me jump to example 3. Now, the question says the same in terms of the sketch, but they want the actual percentages within 3. And I just forgot to mention that I'm just going to label this as 68% just so that you guys have it. So 68% is within those two. And then the problem that we're doing here, they want 3 standard deviations away from the mean. And that's within. So technically that's mu. That's 1, 2, and 3. So this will be mu plus 3 sigma up to there. And then 1, 2, and 3. This is mu minus 3 sigma. So we're talking about that portion. Don't forget the arrows. And technically the portion that we're interested in happens to be this portion here. We're going to need a sentence, and the sentence is going to be identical to the previous one. The only portion that gets modified is the percentage. So technically by the empirical rule, you're going to have, and within 3, so within this portion and that portion, you're going to have the 99.7%. So you have approximately 99.7% of data within 3 standard deviations above and below the mean. So that's it for intervals that actually happen to be symmetrical. You're talking about, well, 3 above, 3 below is 99.7. 2 above and 2 below, it's 95, and then 68 within 1. Now, not all of your intervals are going to be symmetrical in this form. You may have some that are not symmetrical. So I'll let you guys do example 4. I'll do example 5. And then in this case, they're stating that your data is bell-shaped, so that's good. That means we're going to be using the empirical rule. And they want us to shade the percentage of data that is 2 standard deviations below the mean. So in this case, below the mean, it's actually going to refer to, this is mu, this is 1 and 2, this is mu minus 2 sigma. So we're going to use this portion here. And let me just highlight that portion. And then it says, in 3 standard deviations above the mean. So technically, let me just use a different color here. So this is going to be 1, 2, and 3. So this is mu plus 3 sigma. Okay, so let me take a look at this percentage. So let me erase this. So we're taking a look at this portion here. Now, if we were talking about a total of 3 standard deviations, in this case, that would be your 99.7. So this portion here is going to be your 99.7 technically percentage divided by 2. That's going to be half of the distance between mu to a total of 3 standard deviations above the mean. So this one doesn't say within, it just says 3 above it. So 99.7 divided by 2, I'm getting that this is 49. So 49, 85%. This is just for the actual, for the above. The below one, so this portion from here to there, it's going to be half of 95%. So 95% divided by 2. This is 47.5. So that's going to be the portion that, or half of the portion that's technically below. Now, total area or percentage. It's equal to your 47.5 plus your 49.85%. So it's going to give you a total of, and please check this to make sure that you're matching, 97.35%. That's what I'm getting on, well, only 2 below and 3 above. And you still have to technically conclude the same sentence, except that we just have to mention in this particular one that it's not within. So this is still mu minus 2 sigma. So the total area, we ended up with 97. So 97.35%. That's within. And then this one is very specific. 2 standard deviations below the mean. Let me fix it. And 3 standard deviations above the mean. So we have to be very specific to what is it that we're talking about. If it's a statement of within, it's understood that it's symmetrical. Your intervals are symmetrical, but you cannot always conclude that on these distributions because we're looking at specific scenarios. At the moment, we don't have any numerical values, but you have to be aware that you may not be looking at, well, a symmetrical interval.